Good morning, all of you. Welcome to class number 7. In previous class, we have already discussed the Coulomb's law in vector form, both case 1 and case 2. But today, now discuss about case 3. Case 3. Case 3 is what? Case 3 is with rest to position vector. Suppose two charges are there. One is Q2, second one is Q1, Q2. Suppose this position vector from 0 to origin, this is the origin to Q1 named as R1 vector. Similarly, this is the R2 vector. But this vector, there is two displacement vector are present. There is two displacement vector from Q1 to Q2. This is this direction, and another is this direction. Yes or no? Suppose we have already known in first year class, when A vector is present, when B vector is present, it's the same order, but C is the vector is opposed to the both A and B. So the formula is generated from this expression: A vector plus B vector is equal to C vector. So similarly, that displacement vector from Q1 to Q2, that is, suppose that is the name is X vector. So by this formula we can get the R1 vector is this direction, R2 vector is this direction. This means R1 vector and X vector is same order. That means R1 vector plus X vector is equal to R2 vector. So X vector is equal to R2 vector minus R1 vector. So this displacement vector from Q1 to Q2 is named as R2 vector minus R1 vector. Similarly, Q2 to Q1 vector is named as R1 vector named as R1 vector R1 vector minus R2 vector. Yes or no? So but now we know force F is equal to beta Q1 Q2 by R square. The vector form is R unit vector, or it is also named as F vector beta Q1 Q2 by RQ into R vector. Yes or no? So suppose this is the Q1 charge, this is the Q2 charge. So whenever force between similar charge means force between like charge. This is the positive charge, this is the positive charge. Suppose the force is active on this charge is this direction F12. Force active on this direction, this is F21. So F12 vector is equal to beta Q1 Q2 by Q1 Q2 by F12 beta Q1 Q2 by F12 is in this direction. In this direction is same direction to which displacement vector? This direction, that is the name as R1 minus R2 Q into R1 minus R2 vector. This is the F12 vector. This is the equation 1. Yes or no? You have to note down. Similarly, F21 vector is, so similarly F21 vector beta Q1 Q2 by R2 minus R1 Q R1 Q vector चिन्ह are available in R2 vector minus R1 vector. This one. So this is the F12 and F21. Similarly, we can write here, we know here we know R1 vector minus R2 vector in magnitude is equal to R2 vector minus R1 vector magnitude. But R1 vector minus R2 vector is equal to minus R2 vector minus R1 vector. Same magnitude but opposite polarity. So putting the value of R1 minus R2 minus R1 here, putting the value of R2 minus R1, then we get F21 vector is equal to beta Q1 Q2 R2 minus R1 means minus R1 vector minus R2 vector whole divided by R2 minus R2 vector minus R2 vector minus R1 vector magnitude is equal to magnitude of R1 vector minus R2 vector. So we can write instead of R2 minus R1, that is R1 vector minus R2 vector Q. So imply that F21 vector is equal to minus beta Q1 Q2 R1 vector minus R2 vector divided by R1 vector minus R2 vector Q. This is the value of F12 vector. So finally F21 vector is equal to minus F12 vector. Yes or no? So you can write. So similar result is similar. That means case 1 we find out the result F12 vector of F12 is equal to minus F21 vector. Similarly case 2 F12 vector is equal to minus F21 vector. Similarly case 3 F12 vector minus F121 vector. That means in every case the magnitude of force is equal but in opposite polarity. So that is why the opposite, due to opposite polarity of force, so this force is also called as central force. This already you have already written. So that force is named as which force? Central force, or alternative named action and reaction. If F12 is action, then F2 is reaction, because F12 is the opposite polarity of F21. Yes or no? So, but now after force between two charges in vector form, about number of 3 cases, case 1, case 2, case 3. Then after you have to retain some notes. Yes or no? Some notes the about magnitude of force and direction of force. So notes magnitude of force, and this is my direction symbol. Magnitude of force and direction. Yes or no? So first point, magnitude of force is equal. Magnitude force is equal. Magnitude of force is both are equal, or magnitude of forces are equal, and it determined by Coulomb's force, Coulomb's law. I mean, the magnitude of force is determined by Coulomb's law, which you have already known. F is equal to beta q1 q2 by r square. Due to Coulomb's law, we can determine the force between two charges, and direction is determined by direction of force is determined by sign of charges. Sign of charge. If your positive charge is here, your negative charge is here, then force is attractive. Yes or no? If positive charge is here also positive charge is here, the force is repulsive. This force is repulsive. That means attractive force, direction of force means force act on this charge is inward, attractive in nature, inward position. But in this case, force act on this charge is outward position. So direction of force is determined by sign of this charge. Yes or no? So this is your note about magnitude and direction of force. Yes or no? Similarly, next point, when force is repulsive, when force is repulsive, the direction of force is push away. Direction of force push away. Suppose this charge is repulsive, positive charge, repulsive. Push away. This force is this direction. This force is this. That is called push away. Yes or no? When force is attractive, the direction pull away. The direction pull away it. That means when our positive charge is here, negative charge here, the force act on this charge is this direction, this direction. Force act on this charge is this direction. This is pull away it, pull away it. Yes or no? So you can note down. The next point, the magnitude and direction of force. Next point is the direction of force. The direction of force is along the line joining the two charges. This is the last note of magnitude and direction of force. Yes or no? So, but now we can study the comparison between Coulomb's law. Coulomb's law means Coulomb force or gravitational force. Yes or no? You have already known the gravitational law of force in first year class, but now you have already studied the Coulomb's law of force, Coulomb force and gravitational force. You can note down the comparison between Coulomb force and gravitational force. Yes or no? So here left side is the Coulomb force, Coulomb law of force, the gravitational force. Yes or no? First point. The Coulomb force, you have already known. Coulomb force, it may be attractive, it may be repulsive, it may be attractive or repulsive, but it always attractive. It always attractive. It is always attractive. You have already known in first year class. Gravitational force is only attractive. It is always attractive. Yes or no? It is always attractive force. It is a strong force and central force, Coulomb force. It is strong force and central force. It is central force because anybody is attractive to the center of the earth. So that is why it is central force. Yes or no? So it depends upon medium. It depends upon medium because you have already known force between two charges. Then medium is different, then force is different. So that's why Coulomb's law of force depends upon medium of the medium between two charges, but it does not depends upon medium. It does not depends upon medium. It is conservative in nature. It is conservative. It is also conservative. Yes or no? it depends upon distance between two charges. But so F is equal to beta q1 q2 by r square. Here F is equal to G. F electrostatic force Fe with the gravitational force Fg. G m1 m2 by r square. Yes or no? You can note down. Yes or no? Similarly, next point, it depends upon nature of two charges, but it does not depends upon nature of two masses. Yes or no? The short range force, the long range force. Yes or no? This applicable for point charge. This applicable for any mass. So no, you can note down. Now the relation between electrostatic force and gravitational force. That means relation between electrostatic force is denoted as Fe, and gravitational force Fg. So we have already known. Suppose Fe is equal to beta q1 q2 by r square. Yes or no? Suppose q1 and q2, the charge of either electron proton or proton electron, or both are electron or both are proton. But magnitude of charge of electron is equal to magnitude of charge of proton. So that's why we can write q1 is equal to q2 is equal to 1.6 into 10 to the minus 19 coulomb. So Fe is equal to beta value is what? 9 into 10 to the power 19. And my dear students, in class 5 I have silly mistake. Beta is equal to 9 into 10 to the power 19 Newton into meter square per coulomb square. Newton into meter square per coulomb square had written, but actually this is my silly mistake. But value of beta is equal to 9 into 10 to the power 9. Actually 9 into 10 to the power 9. So beta is equal to 9 into 10 to the power 9 Newton meter square per coulomb square. Yes or no? So you will correct in your updated note the value of beta is equal to 9 into 10 to the power 9 Newton into meter square per coulomb square. Yes or no? So here F is equal to beta, value of beta is put 9 into 10 to the 9 into 1.6 into 10 to the minus 19 square. Because this value is same value, so that Q1 multiplication Q1 and Q2 is square. So by divided by R square. This is the equation 1. Similarly, Fg is what? Fg is G M1 M2 by R square. Suppose we have to compare the gravitational force between two electrons, or two electron and proton, or two protons, or two proton and electron. That means Q1 Q2 or M1 M2, either force between electron electron or electron proton or proton electron or proton proton. So the mass, suppose we have already known the gravitational force, the only attractive. Gravitational force, the only attractive. Only attractive. So that is why this is also, if this M1 is the mass of electron, but M2 is the mass of proton bound, because this charge is the opposite polarity, because this mass is the opposite polarity, because this is the attractive force. Attractive force, when attractive force is produced, whenever either positive charge negative charge or negative charge positive charge. So if M1 is the positive, then M2 must be bound is negative. So if M1 is the mass of proton, so M1 is the, if M1 is the mass of proton, then that is equal to 9 point, proton value is what? 1.67 into 10 to the minus 27 kg. But M2 is mass of electron. So this is the value is 9.1 in 10 to the minus 31 kg. But here you again repeating the electrostatic force between two charges. This electrostatic force you have already known, this may be attractive, this may be repulsive. So this charge either electron or electron proton or proton electron or proton proton. Yes or no? So here electrostatic force is possible either attractive or repulsive in this, but in gravitational force M1 M2 is here, but G, value of G is what? Value of G is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Yes or no? Newton meter square. This unit is what? This unit is Fg into R square is here. M1 M2 is divided. So Newton into meter square per kg square. Yes or no? So Fg is what? Fg is what? Fg is what? Fg is Fg is 6.67 into 10 to the power minus 11 into mass of proton 1.67 into 10 to the minus 27 into 9.1 into 10 to the minus 31 by divided by R square. Again I can write 1.67 into 10 to the minus 27 into 9.1 into 10 to the minus 31 divided by R square. This is the equation 2. This is the equation. Now dividing equation 1 to 2. So Fe by Fg. Fe is what? 9 into 10 to the power 9 into 1.6 into 10 to the power minus 19 coulomb square whole divided by r square divided by Fg. Fg means 6.67 into 10 to the power minus 11. 6.67 10 to the power minus 11 into 1.67 10 to the power minus 27 into 9.1 into 10 to the power minus 31 by r square. This one whole divided by r square cancel. So implies that Fe by Fg is equal to what? 2.2. You can calculate. You can calculate. You can find out Fe by Fg is equal to 2.2 in 10 to the power 40, 10 to the power 39, 10 to the power 39. So we can write Fe is equal to 2.2 into 10 to the power 39 into Fg. That means you have already known the gravitational force. Sum multiplied to gravitational force, we can find the electrostatic force. Here we can already study the Fe electrostatic force is far greater than Fg. So that's why Fe is equal to 2.2 in 10 to the power 39 into Fg. Yes or no? So the comparison between electrostatic force and gravitational force is finished, and relation between gravitational force and electrostatic force already finished. Then after next class, class number 8, we will study or we will discuss the unit of charge. You have already known the unit of charge is what? Coulomb. And you have not known your CGS unit is the start coulomb, half coulomb. In next class, we will study the unit of charge. That means there is two units, the CGS unit and SI unit. CGS unit is what? In SI unit is what? It will discussed in next class, the class number 8. Yes or no? Yes. So thank you.